And that's the goal in grade 5 is really to get them telling us this. Because our grade 5 is where we do this mixed improper stuff. And I think it is in the new curriculum too. I've spent more time with the P to 3. But I think it's still mixed and improper still in grade 5 in the new curriculum. But we want them telling us ways to figure it out. So if I knew I have 4 wholes plus 1/3, if I think about each hole, I'm going to cheat and draw squares because they're easier. Oops, sorry. Thirds. I was thinking 4. Okay, so I would have 3/3 for 1, 3/3 for 2, 3/3 for 3, 3/3 for 4. So now I have 3, 6, 9, 12 thirds, right? Those are all shaded. And then I have one more little third. So I have how many thirds altogether? 13 thirds. Okay? Yep.
I know the thing that we were taught in school was like 3 times 4 plus 1
yeah.
to get you. Is there any way that they'll figure that out on their own? Or is it
absolutely. That's exactly what we just did.
Yeah.
So for each one of these.
So they'll come up with that strategy.
Yeah, they will.
Eventually.
Yep.
Or number line.
Yep. Yep. They could do number line jumps. Yep. So in order to get to 1, I'd have to do 3 jumps of a third. In order to get to 2, I'd have to do 3 jumps. Like you could take a number line, and if you broke your number line into thirds, right? 1, 2. So that's 1, 2. Right? And you can just see there are, right? You can see every time I jump 1, I've counted 3 thirds. So 3 thirds, 6 thirds, 9 thirds, 12 thirds. And kids will get that 12 thirds came from 4 times 3. Right? Because there's 3 thirds in each one. Yeah. And that's the goal, is to get them to come up with those rules, right? Give them the experience, teach them the meaning of fractions, and then all of a sudden they're telling you things like, oh, well, you know, miss, this would have been easier if you just went like 2 times 4. And then you go, well, why? Well, because for every whole, there's 4 halves. So you got 2 sets of 4 halves, which is 8 halves, whatever, sorry, 4 quarters, right? So you want them to come up with that. So you want them to come up with it because they understand what fractions mean, and they've modeled enough that they can kind of visualize it, right? And that's again, another focus of shifting curriculum is to give more time for building those meaning pieces so that we can then begin to do the more substantive pieces later on, and kids have a better foundation. And that goes back to what we were talking about when Shauna was asked the other day. Shauna, it was you, right? You asked about like getting kids confused.
Yeah.
And part of the reason is we're not giving them enough time to build the pieces. We're not giving them enough time, and we're trying to build strategies on an kind of like on a shaky foundation. But what we want is for them to have a good solid sense of number and quantity and proportions and or partitions, like how to break things apart, so that when we start using those strategies, they just kind of see them, right? And they'll emerge. So it's not us teaching them a whole bunch of different strategies. The strategies should emerge from their understanding. So we need to give them the time to develop that understanding. That's part of the move of shifting the curriculum so that it's considerably less than it was before. Okay, what about trying to figure out which one's bigger and which one's smaller? How'd you do that? What?
Yeah, convert them to common denominator.
You have to?
Just draw a hole.
Just draw a hole?
Well, which one do you have to?
Let's do 1/3. Oops, sorry. Let's do this one. I'm just going to make it a little bigger so you can see it. 1/3 and 1/4.
Draw 2 strips and divide one into
we can just draw a strip divided in thirds, and then draw another strip the same size. That's not quite the same size, but let's pretend it is. There we go. And split it in quarters. And I can show that 1/3 is more than 1/4. Now, one of the things we want for kids is to be able to compare the size of unit fractions, and they do that actually typically right now in grade 4. They do a lot of comparing of fractions. So 1/3 is greater than 1/4 because I can see it, I've built it. But also because I know that if I take something and cut it in 3 pieces, each piece is going to be bigger than if I take that same thing and cut it in 4 pieces. We'll often tell kids, you know, which would you rather have, 1/3 of a cake or 1/4 of a cake, right? Do you want to share it with 2 other people or do you want to share it with 3 other people? Well, you know, maybe they're very generous and they want to share it with as many people as they can. But if they want lots of cake, then they'll ask for more. Yep.
The greater than sign. When I went to school, like my teacher tried to teach us like through like the alligator shark scenario.
Yeah.
And I've never really understood it ever since then because the shark thing didn't work for me. How would you teach that?
Well, it's really just a convention, so we might say that this is just a symbol that mathematicians invented, and maybe it's not the best symbol, but it's a symbol that we kind of have agreed to use. And if you look at the big end, it's near the big number, and if you look at the small end, it's near the small number, or it points to the small number, so which one is smaller? But I often think like the size of the spread, so big size, big number, small size, small number. So the pointy piece goes to the smaller number, but it really is a convention and we just have to teach kids. And oftentimes what we do is we get them to talk about the comparison long before we introduce that symbol, so that we're sure they understand 1/3 is bigger than 1/4, because if I take something that's broken into 3 pieces, it's going to be, the pieces are going to be bigger than if I break it into 4 pieces.
Was alligator in the curriculum? Because I remember.
That's what I was taught.
It's just, it's just something that a lot of teachers have developed. The crocodile eats the bigger number.
I was just told.
And some teachers actually do this, like they draw the whole crocodile's face, and you know, you're like, big teeth.
Yeah, so you think that's a job.
Right? So, yeah, I mean, you'll see like actually commercially made math books that have crocodiles and alligators or whatever. But it is just that the bigger end goes next to the bigger number and the smaller end, and it's just a convention.
So it doesn't matter how they decide to remember.
No. I often actually remember that less than looks like an L.
I remember that last points to the left in the golf medals.
But it's not necessarily less than if the bigger number is on the left. Like,
No, but then I wouldn't write it that way.
yeah. No, because what did you say, Emily? Sorry.
Less points to the left, it goes like this.
But the less doesn't necessarily.
But then you
Yeah, no.
So then I just show
numbers.
wrote it, so the one on the left.
Then you'd say greater than.
Yeah, but
So
the
the
mark
mark
itself is nothing until you have the numbers there.
Right. So 7 is less than 10. And
But it
less
needs to
than
have-
looks like
But
an
if you
L.
put 10 on the other side, then 10
Then
is
I would say
greater than.
10 is greater than, and it doesn't look like an L anymore. It looks
Right,
like a
and
backwards
less
L.
is not pointing.
But then it's a
Yeah,
greater than
yeah.
symbol, then it's not a less than symbol.
Yeah, so this
Yes.
is the less than symbol, and this is the greater than symbol. But it's complex because it's a convention, and we teach it like it's like written in a Bible or something. But it's not. It's just a convention, and so most of what we do in mathematics has been developed by mathematicians. It's conventions, right? And we all just agree to do it that way so that we all know what we're talking about. Okay, how would you do 7/8 and 5/6? Did you draw that one too? Which one's bigger?
When do you start teaching to find like a common denominator?
When you start adding, isn't it?
When do I or when do other people?
When should
When would you recommend?
We learn about common denominators in our current curriculum in grade 6, but we get kids to realize that, hey, it's better if I actually can compare these using the same piece, right? So we do a lot of work with equivalent fractions and to generate the notion of a common denominator in grade 6, but we don't really call it a common denominator. We just talk about how the denominators should be the same, so can we make these both proportional with the same denominator, equivalent. However, we would do this long before we ever learned that, because there's an actual better strategy to do this one than common denominator, because if I start doing a common denominator with this one, I get ugly numbers.
I just drew the pictures and tried to figure out Tom looked like.
Okay, one way is to do the pictures.
I think it's like perspective drawing.
It's a little bit close. This one was the one I had the most trouble with of all three.
Now the pictures are ugly, but talk to me about 7/8. What do you see? Small pieces. Why do you say they're smaller pieces?
Because you have to fit more into one area.
Okay, so there's more of the 8s in the same area. So I know 8s are smaller than 6s, right? 6ths. We're still really early in the morning. I know 8s are smaller than 6. How many 8s am I missing in the first fraction? 1. How many 6s am I missing in the second fraction? 1. So if I'm missing 1/6 of something, is that missing more of it than missing 1/8 of it? Yes. So if I have 5, 6 shaded, which one of these is closer to being whole? 7/8, because it's 1/8 away from being whole, whereas 5/6 is 1/6 away from being whole. So if I thought about these on a number line, here's 7/8, here's 1. It's this distance away. Here's 5/6. It's this distance away. Which one's closer to 1? 7/8. Okay? So I know 7/8 is greater than 5/6 because 7/8 is closer to 1. Okay, so that's using a benchmarking strategy and kind of knowing the size of units, but now we're missing one unit. So the smaller one, if we're missing one of them, is actually the bigger fraction. Okay, the one with the smaller piece. Okay, so what about 3/4 and 2/3? Could you do that one the same way? Yeah, which one's closer to 1? 3/4. Yeah. This one actually, by the time kids get to grade 5 or 6, they should just know this one because I don't know, is it not the same question on your sheet? Okay. Well, look at that. It was supposed to be 6/12 and 5/12?
6/10 and 5/12.
Oh, because I changed it in the sheet this year, but I didn't change it on my smart board. Okay, so let's do that one.
6/10.